Patrick. I just started in Seagate in January, and I have a mentor, Andrew, so his name was also in the title of this talk. So I included him if Andrew wants to introduce himself. I think he's on mute, so it might just keep going for now. So yeah, I'm just going to talk about how to tune, configure, and install Motr. I just said how to Motr. I know that doesn't really make grammatical sense, but I just thought it was a bit sharper than what I just said anyways. So yeah, I started at Seagate in January. I'm a developer advocate. So supposedly I'm supposed to be an expert in installing and configuring Motr, but we'll see. You can tell me if I am at the end of this. So what I'll talk about is what is Motr, sort of like why anyone care about Motr, and then how to install and run a Motr cluster, and then how to configure and tune a Motr cluster. So I recorded a video of me installing and running Motr, so because I didn't want to like have 40 minutes of just me typing commands in the terminal and everyone just watching that. So at least the video, there's some parts that are sped up that take quite a bit of time, so I won't waste too much time. So yeah, what is Motr? So Motr is like the entire like motor of CORTX. It does all the typical functionality you'd expect from an object storage system. So Motr also works directly with the actual block devices rather than building on top of an already existing file system. So there's like this paper that I was reading, and it's linked here at the bottom, like if you can see my mouse there. So it's called File Systems Unfit as Distributed Storage Backends, Lessons from 10 Years of Ceph Evolution. So like Ceph built their object store on top of a file system that exists. So then this paper is kind of talking about why this wasn't the best idea. The kind of motivation that they had. I'm just like giving a high level of the paper because I didn't really understand that much, but I understood the conclusions. So the problem was kind of like that the idea of using the file system was like it's going to be a lot less difficult for developers to make this because this was going to take a lot of time to build the backend. But then they figured out that in this paper they figured out that it's not actually that difficult to build a backend. So not using block, not writing directly to block on your own adds like a lot of complexity to the system and can reduce the performance. So it actually turned out to be a better idea to just go straight to block, which is something that Motr got right because they interact directly with block. And Motr is built and designed for mass capacity. So like kind of the destiny, I guess, or like the unique selling point maybe or something of Motr is like that we want to be the best price per bit object storage in the market. So that's kind of like the goal. It's not really true to say that yet, but we're working towards it. There is quite a bit of work to do with Motr and CORTX as a whole. So then, like, why care about Motr? Like, well, like with any open source coding project, it's visible to the world. Like, so, like, even if you don't care at all about Seagate or object storage or, you know, like that. But I don't know why you would like Seagate's great and object storage is cool as well. And it's really interesting. Um, you know, like you can show this to like recruiters or stuff like that as well. So there's something in it for everyone, I think. That's just me doing my job, I guess, because that's like my role is to promote this open source project. So yeah, and Motr has like big plans and CORTX as a whole has big plans, but haven't fully reached everything. So like there is a lot of scope for like things you can do. I got to add a feature to M0 Create, which is like this benchmarking tool that Motr has where you can read and write, and it gives you like the bandwidth speed, um, or the bandwidth like of the data you've written and read. So that was pretty cool. I thought that was really interesting that I got to be able to create a feature for that where you select the pool. So like the pool is just like the physical devices that you're using to read and write to. So like there's this Sage project where um we have like Motr as the object store for that this rack, and it's an EU project, and there's like non-volatile RAM, there's SSDs and hard drives as well in this rack, and you can choose which like pool you want to write to. Like you want to write to the SSDs, the HDDs, or the non-volatile RAM. So I added that feature to M0 Crate, which I thought was pretty fun. I like that. Getting to code was pretty cool as well. So like Motor's also like a pretty new community. Like it's not even been a full year since the open source has been released. Well, I suppose it's actually been a year now, but it's pretty young. So like it's an opportunity to be like a big part of CORTX here. Yeah, and if CORTX is used in big companies or like even used um becomes big on the market, like you can see that you were part of that, which is pretty cool in my opinion. And then because I'm shameless, I'm saying great support because that's my job. So I'm just giving myself that pat on the back. And then I have the video that I made just to show how to install Motr on a VM. So I just used a VM. So I'm just using a VM workstation. So I use CentOS 2009 version. And then yeah, I'm just creating the VM. Um, this is like pretty cool as well about Motr. It's like it's really lightweight. Like I have not used like it's a very crappy machine. Like if this is your PC, you would not be impressed at all. Like with 1 gig of RAM, one processor, and I only have 20 gigs of uh, hard drive space, and I'm able to run Motr in this VM. So that's pretty good. Like if you want to run Motr, you don't need a good computer. And so then like every time instead of VMware, you need to configure these network settings at the start. And a little bit annoying from VMware, but I just said I'd show everyone because in case you go installing Motr yourself. And then this is Hair, like so. Um, I'm installing Hair here, which is like kind of like I think of it as like the puppeteer for Motr. Like it kind of just controls Motr. It's like telling it to stop and to start, passes it like all the parameters and everything. Um, and then you need CORTX utils as well. So it's just like another um, CORTX component that you need to install in order to run Hair. And to run Hair, to run Motr, you need to install and build Hair. So that's why you have to do all this as well. Um, but this doesn't really take too long. I think it took me like the full video was 35 minutes. Um, installing CORTX utils, CORTX Hair, and CORTX Motr. So it isn't really that much work. I don't think, anyways. I don't think 35 minutes is too much, but that might just be weird. Um, so yeah, just then like building Motr as well is like pretty quick on its own. The main things that take kind of a bit of time are like this install dependencies. That kind of took like maybe 10 minutes, and then the makefile for Motr as well takes like almost 10 minutes as well to run. So I'm just like changing that to be my network interface. So that's what I was doing there. And this is just loading in the Lustre network. And then this is the makefile. If it's going too fast as well, actually, I need to check the chat. Sorry, if anyone's saying anything. Don't know where. No, Yeah, so I'm just linking, telling here like where to look for the motor files here. And so that's all these steps do, and then you have to run the make files for here. So it's just building and installing here, that thing. And that they run pretty quick as well, like maybe 5 minutes for the two of them. And then this is just like copying the sample cluster description file. So that's like the file that here uses to configure Motr, telling Motr like how to run everything sort of. So like the pool size, like what disk it's using and all that. So this is kind of it here. I'll open that up at the end and show you as well. You can change like the priority group, so like what sort of redundancy you're using. So I'm just making like loop devices as well here so that I have something to write to rather than have no like have only the one disk. So then this is just the M0 crate. So I just made like a temporary file. Um, and then this is the M0 crate tool that I was talking about. It'll show you the kind of the bandwidth for reading and writing. Yeah, so here you can see, so I just had read and write, but you can also do like other operations here. I think it's create and delete. I forget what O stands for, but there's 5 different operations you can do. Gives you like the size of the data that it read and that it wrote, and then the bandwidth for that data. So then this is the um, M0 creates YAML file that it uses. So like this is the um, Motr address, the here address, and then this is like a profile of the pool. So like when you change the pool, you have to change this profile address, and this is the process address for Motr. So like what process of Motr you're using, and then these are kind of like different things you can change, like how much I/O you want to read and write, um, how much I/O you want to do, like the block size, threads, if you want random or sequential I/O, the number of threads, and then which source file you're reading your data from. So that's going to that video. And then I have another one then of the making a cluster of Motr nodes. And this is just only all you have to do is like clone the VM. It's pretty simple. And then just there's like a guide here on the Motr wiki, how to build Motr and run a cluster of it. So then you just kind of set it like turn off the firewall, make sure Linux is disabled, copy your public SSH key from like, so you have to choose like a main node and then children nodes. I don't know, you can pick different names for it, like, but kind of what I mean here is like you need one node where you like run pair and bootstrap pair. So like one configuration file for that points to the other node. So like I just call the node that I don't run hair on to be the main. I don't run hair on to be the child node, and then the one that I run hair on, I just call the main node. So hope that explains it. And yeah, so I'm copying my public SSH key onto the child node and just making sure that it works. So yeah, I'm able to connect. And yeah, so just like setting up so I just set up passwordless SSH in, so I don't have to, when I run the bootstrap, it doesn't have to ask for my password. So I'm just setting up password authentication to no and commit root login access to be without password. And then on every node that you have in your cluster, you have to like create the block devices, because the configuration file is looking for those block devices on every. So as you can see here, when I change the uh, cluster description file, I add in the new node. I add in all this data about the new node. So like you can see all the block devices are being looked for. All the loop devices are being looked for. And then I just use the IP address of the like child node for so that it points to it. And then you just get this information, and then you use this to edit your M0 create file. So when you run HTTL status, like it's like status of your current Motr cluster. So there's like a pool name. So like if you had more than one pool here, you would have like say, I don't know, just say the next one below was like foo, and it was 4D at the end here instead of 5D. So that's how you would, and then you would set in here pool FID equals whatever here. So you can choose that as well. But I only have one pool right now. And so then this is the profile FID. So then you put that in here. And then this Motr local address comes from here, like the M0 client that you use. So this is the one that I'm using here. For some reason it's truncated there, but it should be, they are exactly the same because it does work. And then the Motr hair address here is this fax address here. So this is like the hair address. So these could be the same. I'm not sure why it's like truncated here, but it's not important. And then process ID, you get that here from the M0 client. So here, this should, yeah, so this is the same as this here. And then you can kind of configure whatever else you want here. And so there we got um, these results here. So for, yeah, 4 MB. And now I'm just changing the pool here. So this loop device on the like child node, as I was saying, like the node that's not the one I'm running here on here and bootstrapping and like pretty much doing all the operations on here. I'm just going to use that as the pool. So then you have to like, sorry, that's annoying. So I get um, a new profile ID here. So this is different from this because I changed the pool. So now I need to shut down the cluster and then um, change the M0 create YAML file, and then bootstrap the cluster again, and then I can do the same thing again and get results for benchmarking results. So all I need to change is the profile FID. So I made a note for myself there, but I think like I thought maybe it was like because I'm doing some like uh parallel writing because I've added the extra node, but Google actually is only pointing to one loop device, so it's not actually that I'm doing any parallel writes. I don't think. I think it's more likely that it's like caching. is the reason that I'm getting this like improved bandwidth. But I'm not 100% sure why it's getting better. It is a VM, so it's not really like a good way to be doing performance tests. It could also be like I was added more, uh, turned on more applications on my computer or something. But yeah, that's it. I also have the config file open as well. Doing the, but other than that, I can just take questions, like, because that's kind of all I had to show. Another thing as well, like, is this here. So like, um, I've since changed this, but like when I was doing the video, I was using 1 and 0. So like my like parity group is like 1 plus 0. Like you can have like so like I have 2 parity units. So for every like 8 data units I write, I also write 2 parity units that go along with those 8 units of data here, based on this configuration here. But you can also change it here so that you have like 2 spare devices and 2 parity units, or any combination really. If I wanted to change it to uh, 1 and 1 here, then this is just like RAID 1 where it's like mirroring. So like every data unit I write, I also write parity of that. Um, yeah.
I've turned on the setting that allows people to unmute themselves if we want to open it up for a discussion. Patrick, you blew through that. That's 20 minutes. So we have some time if we want to dig into anything. You can, I know you have something you've been working on, but you may hate me for this, is I know you talk about how to tune Motr, but maybe, a little chat about like scenarios in which tuning Motr would be advantageous if, and people can ask questions too if they'd like.
Um, yeah, well, I guess like you can, when you're creating your pool here, say like if I added more devices here, see these are commented out now, but like if I added in more um loop devices, like if I commented out a few of them, you would hope to see like increased bandwidth because you're getting some like level of parallelization there where you're writing to different um devices and reading from them. I mean, as well, like with the parity as well, like that's, you can change that to suit your need as well. Yeah, I'm not sure what else off the top of my head.
Well, just I remember we were having that discussion. And it was really interesting about kind of scenarios in which changing, some of these settings, has an impact on kind of like your outcomes and also like, based on your setup. I know that we were discussing kind of like a scenario in which you pretended that you were Netflix, or, kind of like when we had uh Dr. Samadar on talking about like the UK Atomic Energy Authority and kind of like how they optimize for doing simulations. Um,
Yeah,
so
well,
it's like there's a lot of stuff I remember that we were discussing about that was kind of interesting.
yeah. I kind of drawn a little bit of a blank on that, but I do kind of remember some bits I was trying to think of. But yeah, like I mean, with the parity, if your like main concern is um security, like this sort of RAID one is, or data integrity, like this means that every time you write some unit, it's also copied on somewhere else. Whereas like if you were um if you were just doing some like erasure coding, then your reading and writing is your performance there is degraded a little bit because you have to like do some read modify writes if you don't have like the data units the same as your write. So like say you have 8 data units and each unit is 1 megabyte, then you have like 8, you're trying to write 8 megabytes, and then for that 8 megabytes, and you calculate 2 megabytes parity. And then if you want to write 10 megabytes to that in one go, you've like to create 2 different what do you call like network connections. Like you're sending 2 data units across if you're using 10 megabytes. So then there's 2 megabytes that are in like a separate packet that's being sent across the network of the system. And then when you're writing those 2 megabytes, you'll have to do like a read modify write because you go to write the 2 megabytes, but Motr will write 8 megabytes, but has to read up the other 6 megabytes, calculate the parity for that 8 megabytes, and then write that 8 megabytes down. Does that make sense?
Yeah, I think so. To change the subject a little bit, we have a question in the chat, which got an answer in the chat, but I thought we might get it on the video too, which is, do we need to add disk refs to the pool section, or will the pool be automatically spread across all data disks? Maybe Andrew wants to jump in and answer this since he was already doing so.
Yes, if there is only one pool in the configuration, the disks will be spread automatically from all the nodes to this one single pool, right? But you may have several pools. For example, you have pool of ordinary HDD disks, and you may have pool of SDT disks. So you may want to create 2 tiers of these storage devices, tier 1 for SDD, tier 2 for HDD. So in this case, for each pool, sysadmin have to specify the disks explicitly for each of the pools.
Awesome. Let's see. We've got another question down here.
So is Motr only running on specific Linux kernel, or does it work across all distributions? It works on CentOS and works on Ubuntu. I can't remember what the versions are, but I think Andrew, you know.
Yeah, I can answer that. So on CentOS 7, we have Linux kernel 3 something. On CentOS 8, we have Linux kernel 4 something. So on both these kernels, Motr can work right now. For Linux kernel version 5, it has not ported yet. So version 5 is used in Ubuntu 20. So on Ubuntu 20, it cannot work yet. But on Ubuntu 18, with the Linux kernel 4.15, I think, yes, it should work. I tried it. I tried that, and it should work. Yes, but the main platform is CentOS 7 right now, and it was recently ported to CentOS 8. So you can try on CentOS 8 as well.
Okay, and then another question is, can you talk about how to read the allowed failures parameter? Specifically, where do we specify that 2 nodes are co-resident within the same cluster? And also, where do we specify that 2 nodes are co-resident within the same fault domain?
I'm not really sure. I don't understand. Do you know, Andrew?
Can you open this configuration file, Patrick?
Yep.
Yeah, So yes, so allowed failures parameter, it allows to specify the failure domain, but this of course depends on the number of nodes, on the number of disks, etc. For example, if you have only one data unit and one parity unit, you cannot specify, you can fail only one disk in your pool. So you in allowed failures, you can specify only disk one. But if you have, for example, if you have 6 nodes and each node having some considerable number of disks, like 80, and you have parity configuration 8+2. In this case, you can specify that you can fail you can tolerate the failure of one node also. It's calculated a little bit tricky, but all goes from this parity configuration 8+2. For example, when you have at least 6 nodes, distribution of the parity groups will be done in such a way that no 2 units from the same parity group will happen on the no more than 2 units from the same parity group will happen on the one node. And that's exactly the reason why you can tolerate the whole node, because after this you still will be able to recover each parity group. And of course, the more nodes you have in your configuration, for example, if you have with 8+2, if you have 12 nodes, you can tolerate the failure of 2 nodes, well, and so on. I'm not sure if it makes much sense.
Yeah, I was the one who asked the question. Am I audible?
Yes.
Perfect.
Yeah.
Yeah, thank you for answering it. Like, I guess at a broad level, my question is like, is control a node? Like when we're specifying like a fault domain, I understand that we can say here only 1 or 2 disks can fail based on the parity units, but it's also possible that a fault domain is like a node failing. So is control CTRL, is that the one which is a node?
Yes, I think so, yes.
And how do we say that like 2 nodes are on the same rack or on the same site? How do we pass that information in this like YAML file?
That's a good question, actually. For which
That's fine. I can like post this question on Slack and maybe we can.
Yeah, to be honest, I don't have the answer just
Sure.
yet, and I'm not sure we can specify the racks or sites here. The work on the multiple sites is still going on. It's not there yet.
That's fine. I guess my primary question was whether control is a node. So I think that's good enough for me. Thank you.
Yes, control is the node. Control from the word controller, actually. Controller.
So Andrew, Madhav here. So recently what we have done is that we have mapped a node to the enclosure because we saw that some of the enclosures have 2 controllers. So they have their own disk groups. So if we for all the current scale out, we are saying that node level failure domain will be there. Node level or controller level failure domains will be supported. Okay. So if enclosure is set to 1, then if that is allowed as per parity configuration, then we can continue with that. That enclosure is 1 means one node failure domain can be supported.
Yeah, thanks for the help.
There's another question, which is, does Motr and Hare have a Docker image, so we could just run Motr by loading the Motr and have Docker image file? Maybe it's not here.
Yeah, so it's a little bit a problem right now because Motr has a Linux kernel module to be able to work with Allnet, which is a networking module from Lustre we use currently. So because of that, we don't quite the Docker is we cannot use Docker. We need the whole virtual machine for this because part of the code is working in the kernel space. But there is work going on to replace Allnet with how is it called? Motr.
Yeah, it's a libfabric which provides both RDM interface and TCP interface. So that with that we are hoping that everything will be supported in user mode. So we plan so with that we plan to have Docker images. So in containers we can run the stack. So that is ongoing. I think we'll confirm it later.
Yeah, thanks, Madhav.
Okay, do we have any other questions? You can unmute yourselves, you can drop it in the chat. I'll just give it a minute for anybody who wants to speak up. Let's see, is it possible to run Motr in standalone mode without CORTX hair?
Actually, you can run it, but only unit test or system tests. Well, so there is not very much use of it, but yeah, the whole purpose of hair is to be able to run a cluster with Motr. So without hair,
actually hair provides all the events. So Motr knows about all the events happening in the cluster from hair. So it's just standalone. We can just do happy path IO, but yeah, it's for for production cases it is not recommended.
Yes,
I think we have single node utility in the repo. You can refer that to do the standalone IO with only Motr.
Yes, but if you are a developer for development purposes, there is possibility to run some fake cluster without hair. It's used in the system tests in Motr. You can see the examples in the scripts file. Also, when you check kernel dependency, let us know how to install it.
Kernel dependency.
Shall I read it out?
Yeah, if you want to.
Yeah. Is it possible for you to share the kernel dependency and let us know how to install it? Because for production use and scalability testing, the VM is not performing well.
Not sure I understand the question, to be honest. Does it mean you want exact kernel version which we support, or?
I think they want the kernel dependency so that they know.
I think
they know what.
Yeah, let's take the example of CentOS 7.8. So we have different kernel versions on it, right? So I think Motr supports any kernel version where we will be able to build the cluster and just install it. I think we are not saying that as soon as you have Lustre interface ready, Lnet interface ready, Motr works there.
I see. So you were mentioned that you guys prefer using VM because of the kernel stuff.
No,
So
that is for containers only, we are saying. So when we have containers, right, their kernel model dependency comes into that. For VMs, it is fine. In VMs, we can build any kernel models.
Yeah, so instead of giving us a VM, perhaps you can let us know how how to satisfy all that kernel dependency. Because if you can build VM, I guess you can also set up a server with the same guidelines, right?
Yeah, well, you could have. Yeah, I could have set this up on like a server that has CentOS
Yeah.
as the operating system. Well,
Yes,
I just did
because
a VM.
because in the VM you cannot, like, it's, to be honest, it's hard to type something, like you cannot copy paste, right? Is that only me, or
Oh,
like in the
that's true. But like, I just use Git bash to do that. Like, you can copy and paste from this, and this you just SSH into the VM.
Oh, so yeah, SSH to the VM.
Yeah, SSH is
Yeah.
yeah.
But yeah, and in my case, I need to deploy multiple server.
So if you
And
have, yeah, you are saying that you have physical servers, you want to deploy there, right? I think
yes,
having physical servers is, I think, it's supported. It is, I think, it's still same method you can use. There is no difference actually.
right,
Yeah, like you just need to have like the IP address for the server, just so this
right,
configuration
yes,
file can point to that server. That makes sense.
okay, yeah, that makes sense. Right. Thanks.
No worries.
Yeah, I think if nobody else has any other questions, I think we can wrap this up. Thank you so much, Patrick, for leading this, and for everybody else for jumping in for the discussion. Let me grab the screen again for a quick second, so we can do our normal closing, where I remind you that that we can be found at cortex.link/GitHub. If you're not already on our newsletter, but I suspect you already are because you here. The newsletter is cortex.link/newsletter, or you can request a sticker, cortex.link/stickers. Although I will say that our delivery time on those is a bit slow because we wait until we get a good chunk and then send them all off. So yeah, and I hope to see you guys next month. An important note is that we will be switching out of WebEx into Teams, so there will be a new link, and that information will be available in the newsletter and in Slack and all the regular places. So thanks, and I hope everybody has a great day, and it's a little premature, but also a great weekend.